Hey guys, so today I'm going to show you how to fill out the data tables for the Quadrat sampling lab, part of the Population Field Studies lab. Hopefully you've already watched the video of me doing the lab, so you have some idea what's going on. I'll number the videos in what order you need to watch them. Maybe that'll help. All right, so our quadrant was that little pink box that I threw, and that was 49 centimeters squared, okay? Make sure you're putting them in the right spots, okay? All right, my total plot area, that was the entire rectangle that I drew out, okay? So that was 120 centimeters by 60 centimeters, making that 7,200 centimeters squared. And our total sampling area, that means, remember I threw that pink thing out 3 times. So 3 times 49, y'all, 147. I already did the math on a different piece of paper. All right, so total sampling area is just my quadrant times 3 because that's how many times I threw it. All right, so you saw me take this data. The first time I threw it, I got 1 red bean and 0 white beans in my 49 centimeter square quadrant. The second time I threw it, I got 1 red bean and I got 6 white beans. And then the last time I threw it, I got 4 red beans and 2 white beans, okay? So my average density is going to be how many I caught in the total amount. So I got 6 red beans, and I have to multiply my 49. You're going to add these up. So in 147 centimeters squared. So this is just like the rectangle that had the sea stars and the sand dollars. You're just adding up those boxes together to see how many we have total. All right, and so white beans, I have 8 beans and 147 centimeters squared. So I'll plug this data in for you, or you can just watch the video and plug it in yourself. I'll be plugging this into my example one, so you're going to have to copy it over. All right, so estimated population, experimental value. So the way I calculate that is going to be for the red beans. Let me move this over for you. For the red beans, this is my experimental value. I had an average of 6 beans for 147 centimeters squared. This is how many I had, okay? This is how many I counted when I threw my quadrants out. Now I'm going to set that equal to how many would I have in that entire rectangle. So we're just saying if I have this in this space, how many would I have in the entire space? And you're just going to do the math. So I multiply, so 147x, set that equal to, I did not do this math, so be patient with me. So 6 times 7,200, 43, 200, divide by 147, divide by 147. I'm sure some of you brilliant people can do this in your head, but I am not that person. So that means that I should have 294 red beans. Round up to the nearest whole number, because we're not going to have half a bean, just like you wouldn't have half a cow or half a deer. So 294. Now I'm going to switch colors for you. No, let's do red for the white bean. Well, that would have made sense if I had written in red and ignore me. All right, so for the white, we're going to set that up. 8 beans over 147 centimeters squared, set that equal to 7,200 centimeters squared. And I'm going to let you do that math at home because I believe in you. All right, so my actual population, I counted every bean in that bag. So my actual population for the red was 198, and my actual population for the white bean was 205. All right, so the next thing it wants us to do is it wants us to calculate the percent error. How wrong were we? So I'm going to erase this, okay? All right, so percent error. It's on your thing, but to calculate percent error, that equals the actual number minus the experimental divided by the actual times 100. All right, so for the red bean, I'm going to change colors again. Back to purple. So my actual was 198. My experimental, so from my experiment, it should be 294. I'm going to divide that by the actual again, which was 198. Let me do that math. 198 minus 294 divided by 198. So I got a negative 0.48, okay, rounding to the hundredths place. And then I'm going to multiply negative 0.48 times 100 to equal 48%. Okay, that negative sign means that our number was 48% smaller than what we estimated it would be. So percent error is 48%. And I'm going to ask you to do that for the white beans on your own, okay? All right, I'm going to erase that. And this formula is on your lab sheet. So like, don't stress that it's not here, okay? And I'm erasing it. All right, and the last thing we're gonna work through together. So this is application of the Quadrant lab. This question that's down here. Okay, so these are analysis questions. You're gonna need to do most of those yourself using the content from the lab, from the reading, and from this math that we just did, okay? I'm gonna walk you through the first one though, just to get you going. All right, number one, scientists use the average density found in quadrant sampling of smaller areas to make predictions about population sizes in areas too large to sample. So we did the quadrant sampling with my little pink rectangle because that big square was too big to count all of them, just like you would do a quadrant sampling of a specific area of the woods to see how many like slugs are there or how many deer are there. It might actually be better to do like deer, a different sampling, but something that's pretty stationary, so like trees. So you're measuring the small amount because you don't want to have to count the whole thing, and you're going to do some ratio math, okay? Use the average density you found for your beans to calculate predicted population size for the following areas. What do you predict the red bean population to be in a 3,600 centimeter area? So they want you to use your average density. So 6 beans for every 147 centimeters squared. And use that to predict it to be in a 3,600 centimeter square area. So do we remember how to do that? we'll cross multiply. 147x equals, let me do the math, 6 times 36, 21,600, divide by 147, divide by 147, sorry my handwriting's not better. And you would estimate there to be 147 beans in an area that was 3,600 centimeters squared. So 147 beans. All right, and you will do the rest on your own. I hope that's helpful. And if you need any extra clarification, one, you can Google how to do population density if what I'm doing is not helping you, if you need it done a different way. I've also attached a step-by-step picture. And always feel free to email me, but make sure you use the resources that I provide you first, okay? Because they should be very helpful. All right, good luck, guys.